to several times, and it's great for me to come back to meet friends here. And even this time, we are not able to actually physically visit each city, which I really like to do. But it's also good to meet online, and hopefully my session can bring some useful information for you. So my topic is how to leverage Oracle Autonomous Data Warehouse for machine learning environment. So yeah, just a short introduction of myself. So I'm working for Dell Technology. So specifically work for Dell EMC, which is a division of Dell Technology. It's a big division. So so I'm currently titled as a distinguished engineer in a part of Oracle Dell Technology Leadership Program, which has about about 200 pretty much a good engineer. What we do is provide a lot of technical directions or advice for the management and the top management, and yeah. So my specialty is Oracle database and Oracle E-Business Suite, cloud, and the last 2 years I've been spending time researching the Oracle machine learning inside Oracle database, which is today's topic. So I also, as I mentioned, also a frequent speaker at many Oracle conferences in the last 10 years. So as a matter of fact, I actually presented 185 sessions in the last 10 years. And a lot of that included my 2 trips to Latin Americas. So I've been Guatemala and Panama City, and Chile, Norway, Uruguay, and also and Brazil. So it's been great to visit a lot of friends there. So, and the important thing is I do have my blog that actually has all my previous presentations. So this presentation will also be low there. So, but if Groundbreak 2 need my session, the presentation, I will share that too. So that's without going further. So let me just jump into the topic. So today, actually, in 45 minutes, we have a lot of things to cover, but I try to cover touch several related topics. One is Oracle Machine Learning inside database. So how we do, why we do Oracle Machine inside the Oracle database. And what is the technology available in this area. Then we'll specifically talk about one type of database, which is Oracle Autonomous Data Warehouse. And we're going to show that what is special for this Autonomous Data Warehouse that can offer for Oracle Machine Learning topic. Then we're going to use one of the example to show the process, how we do machine learning inside of the Autonomous Data Warehouse. So let's jump into the Oracle Machine Learning in database. So as we know, many of us probably already know that have some experience on data warehousing. So back old days, we not only have a transaction database, we also build a data model, a data warehouse, by collecting all the historical data into this data model. Now, one of the reasons for that is that in addition to data archiving, we want to use those historical data to build a report, to understand what happened before. So for example, for company, we understand the last month's sales. Right? So that's good report. That's actually quite important. A lot of management, the first day, in the office, they want to know what happened last month. So that's very important for them. But if in case something happened in last month or something good thing happened like last month, suddenly I found that my sales is like 30% more than previous month. What happened? What are good things contributed to those good results? We want to know why. So this is we want to dig more. So the data in their warehouse will show us. So obviously we want to know why. We want to continue those why. So those are pretty much for all the history. But then immediate thing is, if they also want to plan like, what happened to next month, what happened to next month's sales. That's actually important because a lot of sales, if they can predict a lot of sales for next month, they also can predict how much they need to buy the parts. They can talk to the supply chain to get more inventory. So that's also quite important. So we suddenly moved to historical data to future data, and also next thing is if we have a way to predict this result, we want to also have this mechanism built in the application. So then if you have a supply chain application, we can certainly if we have this way predict next month's sale, then supply chain application can automatically send the number to the supplier and request more data, more parts. So that's actually a natural curve. So that's why Oracle think, I think, which I also agree, that machine learning is actually the natural maturity of the analytical. So all this, you can see this. So, but how we want to do that? So many machine learning research, they actually build a machine learning server, but one of the big important characteristic of machine learning is that they actually have to use a larger set of data, because the machine learning really is use data to predict the future. The more data, the more accurate data is they can predict a better future, or to learn, to help the machine to learn. So, but then you come up with like how we deal with this data. If you have a huge set of data, if you have a separate machine learning server, then every time you build a model, you have to extract those data to a machine learning server, which takes a lot of time and high performance, and require a lot of CPU or storage resource or networking resource. Why wouldn't they just do machine learning inside database? In this way, we don't really have to extract data. So in this way, they save a lot of energy. So Oracle methodology is move the algorithm into a database instead of moving data from database to machine learning server. So that has been Oracle's strategy. That's something we call in-database machine learning. So all the machine learning algorithm processing is happening inside the Oracle database. And also next thing is a lot of Oracle database itself is actually very is sitting on very high powerful machine. They are capable to do the algorithm process. So as a matter of fact, Oracle already done this a long time ago. They actually had some built-in data mining procedure. Those are data mining procedure are designed to do this type of machine learning capability. So in Oracle 20C, they actually include this called Oracle Advanced Analytical that include all the machine learning procedure and become the one option of Oracle RDBMS database. So in today 12C, if you just install 12C, and that feature is there, but for sales point of view, you probably need to turn on that option. But all the functionality is there. We're talking about all the PL/SQL procedure is inside database. Whether or not you know or not, the fact is there. So if you go to Oracle database, type describe DBMS data mining, you will see that procedure, and you can call that procedure. So it's already there. Even we not realize that. And another thing is not only you can have a procedure. One of the benefits is a lot of machine learning process actually can be implemented inside a SQL statement. So in this case, it's a machine. If you have to write R, or you have to write a Python, you have to write a lot of the code for that. But this case is simply one SQL statement can apply the model. So that's just an example. We're going to dig more. If you don't get 100% understanding here, that's fine. We explain more. So that's why the machine learning is built inside database. They also not only help us to avoid the data extraction, they also Oracle RDBMS itself is very strong engine, and they can do a lot of very good things, including the parallelism. So we all know that when we run parallel query, that Oracle is very strong in parallelism, and if you have a very good number of CPU, they can take advantage of those multi-core CPU, so make it very fast. And another important thing is all the Oracle machine learning, they actually can leverage the single data structure, which is table. So you can store all the data, all result, even the model, machine learning model itself, inside the table. So that's how everything is based on SQL. So in this case, the model itself, NY class 1 model, that model itself is a table. So that's why, because the table, you can run this in the select statement. So you can pass this table in the select statement. So Oracle extended SQL syntax to have something like this to do the machine learning. So yeah, so inside that, and Oracle actually almost include all the major machine learning algorithms inside Oracle database, including those most common ones, kind of regression, classification, time series, all the most common ones already in there. And Oracle are in the process to include the R or Python that can directly support by direct talk to Oracle, the machine learning procedure inside Oracle database. So that's how the Oracle direction. Okay, so I just want to give brief. So for those people who would like to know more, you can research Oracle Advanced Analytical package that actually has many details to go through each procedure, each step. You can learn more. So now we switch the topic to look at specifically how this can be done in the Oracle Autonomous Database. Obviously, everything I talked before, you actually can implement inside of any regular database, which could be in your laptop or could be your data center. But now let's see what is actual feature that Oracle Autonomous Database can offer. Let's get a little bit of introduction about Autonomous Database. So Autonomous Database is built on Oracle Cloud, so which means you can leverage a lot of easy provisioning mechanism, and also all the database is running on cloud, and which means that they also have an autonomous feature that they can do all the patching, all the upgrade, and all the monitoring, so you don't have to worry about all the DBA tasks. Everything is taken care for you. Only thing you need is use that to do your development. So simply DBA task is pretty much done on background by Oracle Autonomous Database engine itself. But as a developer, you can focus on the development. So by different workload, Autonomous Database support a transaction database or the DataWarehouse database. But for this presentation, I focus on ADW, which is DataWarehouse. But actually, transaction database also support machine learning. If you want to explore that also apply too. So you can do that too. So Autonomous Database itself is not just a database. It actually provides the very collective architecture. So if you see the big diagram in the center, so this is actually the Autonomous Database. So it has not only has a database, which is a regular 18 or 19C, in the future they're going to upgrade to 20C. So it is an autonomous plus some of autonomous management features. But for application point of view, nice thing is that they actually include some of the built-in development tool, such as developer, REST API, or Application Express. But today we want to focus on this machine learning, because machine learning, Oracle Machine Learning Notebook, that is a tool that you actually can use to do your machine learning task. And that tool is actually built inside our Autonomous Database. So, but obviously, as a whole, you actually can use your client tool in your data center to, for example, if you want to run developer in your laptop, you could use the developer, SQL developer in laptop point to the Autonomous Database, which is fine. But you also can run BI tool on top of that. So yeah, either way is fine. So Yeah, so I want to quickly go through this. So if you want to try this, you can just go to Oracle Online, Oracle Cloud to request a free trial. So free trial, $300, free credit for up to 30 days. Whichever finish, your free trial will end. But what happened to free trial after free trial end? You have two options. Either you pay, or if you don't want to pay, let's say if you are just for a learning purpose, and I'm not going to run enterprise application, you can stay with without doing anything. They will automatically become always free, which means you don't have to pay. The database will run forever. But they do have a limitation, like they only can have two database instances. Each instance only can have one CPU, 8 gig memory. But nice thing about this is the important features, like Oracle machine learning feature, is part of it. Free, always free, which I'm doing now. So all the example I'm running was actually based on always free trial. So you don't have to buy, so if just for learning purpose. Yeah, so in order to use Oracle machine learning, you have to provision ADW instance first. And that's actually quite simple. You go log into a machine. Once you get a free account, you log into this main page, click autonomous warehouse, and answer a few questions, like how much CPU you wanted, and it will automatically get your instance. So once you get an instance, you can go from there to get a machine learning account. So let's talk more. So we just went through that. Let's see how Oracle machine learning with AWS works. So machine learning itself is actually built into inside of autonomous database, which we just discussed, that allow you to run notebook. This is actually, the machine learning itself include a notebook that's based on Zeppelin notebook. Inside notebook, you actually can run SQL or run SQL query or run SQL pure SQL procedure, and you also can. The important thing is they also provide you a lot of a GUI interface for you to actually look at data in different way, which you're going to discuss more. So all of the data mining procedure can be run, executed in this Oracle machine learning notebook. So, and also all those important algorithm is included inside of Oracle machine learning. Yeah. So you can see the most common used machine learning algorithm, such as classification, clustering, anomaly detection, time series, regression. So almost all you can use that. And we're going to actually pick one of the example later on. And now Oracle, actually talked to Oracle developer sometime. They actually mentioned in Oracle 20C they are adding more features. And so actually this is the area Oracle actively develop new features, and those are this feature allow a lot of developer, like a data scientist who does not have a lot of programming background. So a lot of data scientists, they know data very well. They know algorithm very well. They may not know a lot of technical details, such as and how the database is running in background, and how even they may not know the SQL quite well, and also they may not know the Python or the other language very well, but they can. So this new feature that Oracle is going to develop is actually help them to focus on their business logic instead of get so much detailed technical part. So this is actually, yeah. And one area is, they also know one area is, that a lot of people, today we have Oracle, OML has a lot of function to support SQL, but for some people, like data scientists, some data scientists may know Python R in their background, so they may not know SQL that well. So this this new feature allow them to use Python or R directly access database. So they can combine, but they can choose between SQL or the R. So they also can do the REST API. And another important feature is to monitor the model performance. So as we know that the machine learning model is based on data. So let's say if we build a data model like 3 months ago, and that data model is based on 3 months data. What happens if you have new data coming in, and that data may be different from old data? So you need to have some adjustment. So including rebuilding the model, but it would be nice to actually have someone to tell you that you need to rebuild the model. So Oracle, this 20C has this new feature to monitor the model performance, that they will let you know that it's time to rebuild the data, recommend you to rebuild data. So, and other important area is called auto ML. So the sum of the this actually build a path for us to automate the entire machine learning model process. So for example, the model selection. So sometimes you have data and you have task. You need to know which model you're going to use. We discussed previously, we have so many different models. Which one you use? That's a big question. So auto ML will, based on the data, actually help you to select what's the best model to use for model training. And another thing is called feature selection. So normally, Oracle machine learning is based on data, and importance is based on certain features. So for example, the one we're going to discuss is, in the example is we want to build a model to predict the customer credit. So in order for us to predict customer credit, customer has many attributes, such as the one table we show they have 40 attributes, such as like income and also the profession and family status. And now they may also include some of features such as address, city. So you can tell like some features more important, like income, family status, and the profession, and how much money in the bank and wealth. So you ought to be able to automatically select those important features. So the new feature AutoML will help you to quickly identify those most important features for your model building. So, but this will reduce a lot of manual effort, because if you have a table that has 100,000 or maybe a million row, it's impossible for human being to look at those value. So it's good, if you have an automation process to identify that. And also the auto-tune process, hyperparameter, they also can automatically tune your model prediction accuracy. So for you to get avoid a lot of manual process. So those are the new features on the pipeline, and that will be implemented in the 20C. So those let's jump directly onto how to do this. So we discuss in order for you to use Oracle machine learning, you have to first provision the autonomous data warehouse instance. Yeah, once you have instance, then next step is create a user that you actually can use Oracle machine learning notebook. So the way the design is, any user that in autonomous database that has OML role privilege, that user can access Oracle machine learning environment. So that's the rule. So the way you do that is you come to ADW, this database instance. You come to this select is called Manage Oracle Machine Learning User. So when you click that, you will create a new user. You specify once you create a new user, and automatically, if you click this window, this tab, if you go through here to create user, that user automatically has the developer role for you to access Oracle machine learning. But if you, let's say if you already have an existing user which you created with SQL Plus, for example, you created like a John user, and that user was created from SQL Plus, not from here, then you actually can grant them user. Yeah, so either way, any user who need access to machine learning need to have this developer role for that. Yeah. So once you have that user, then let's see. In this case, I create a user called ADWC_WS. So I create that user and in that database, then I can just use that user to access. This is part of this GUI interface is part of inside of inside of yeah, if you call it server console, you actually they'll give you once you click the server console, they actually open a little tab that actually show you the actual URL. So you can get a URL, which is Oracle Machine Learning URL. That URL is tied to this your actual autonomous database instance. So look at it. OML is always default connect to your autonomous database. That bound is already there. So I'm actually in my book. I actually explained them. I have detail to actually show how these two are bonding together. It's actually quite important to understand that because once you have Oracle machine learning, like this case, like once you log in, if I click running SQL, this was open a notebook for us to write a SQL. Then when you write a SQL, you have to solve two different important questions. One is where the SQL will be executed, and where if the SQL is select statement, where the SQL will get the data. Those two important questions is related to your autonomous database. First one is your SQL statement. As we know, if we run SQL statement, the SQL statement has to be interpreted, executed by interpreter. So this interpreter is actually inside the Oracle database. So that's why your machine learning notebook has to have called an interpreter setting, bounding setting. That the setting actually point to your EDW database. So anytime you type SQL, you want to execute a SQL, that SQL is actually sent into your database to interpret, to execute. The ones is executed, if the SQL statement is a select statement, they also go to database to fetch data. When they fetch the data, they're gonna actually, after they fetch the data will be presented into the notebook, which we're gonna show later on. So this is actually the main page, the machine learning main page once you log in. So click here, you can run a SQL statement as we just discussed. But if you want to run multiple SQL statement, or if you run a pure SQL package, which we discussed, like we run a DBMS data mining procedure, you have to run from here. And either of these actually are the special case of a notebook. So you also can click, say, notebook. You can create a notebook, and in the notebook you can just put the SQL sign that's for running SQL, and a SQL script sign to run SQL script, which we're going to discuss more later on. Yeah. So another thing is important thing is when you click example, they actually show you all the example. As first time the learner is actually strong advice you come here, click this example. This example open all the pre-built notebook. So you can start from my first notebook. This is just like a hello world. If you're running any programming language, anytime you run any programming language, you first write first program is hello world. This is just like a hello world for you to get a notebook. But when you get it more comfortable, you can try more machine learning example. This actually show you how you do that. So now later I'm going to show you one example. The example is not from here, but it's one of the example, a little bit more complicated than this one. But I want to use that to show the different phase of machine learning. So here's if you click a SQL, like see, if I click running SQL here, click this one, I will get this SQL query script. So this just simply edited, just like a SQL developer. You just type SQL, any SQL. Obviously, this goes a little bit more complicated, but if you want, you can just run like select star from customer. That's a single query. And a nice thing about this is if you try that, all this example actually use the table that is already pre-built in the ADW instance, so you don't have to reload any table. So this one is same. So the just like sample schema. So ADW provides sample schema for you to do the machine learning, and this also all of this actually give you sample code to run this and the sample schema for you to learn this piece. So what I want to mention is, so you run a SQL here, and you actually click this. This is already finished, but if you have not done it, this should be ready. They actually change that. So initially when you finish SQL, this is actually show ready. Then you click this the triangle, ask them to execute this query. As we mentioned that this notebook is actually connected to your background ADW database instance. So this query will be executed inside the ADW instance to fetch data. By default, all the fetch data will be shown here as a table format. So that's why this come in. So this actually allow you to actually change, look at the data in different way. By default, this table. So if you don't click here, it's right here. But all the same data, look here, by clicking each of this one, they also show you presented data in different graphical way. So for example, if I click pi, then same query, I run the same query, and they were going to show you the distribution by for example, in this case by profession. So you can see different profession. There's a profession column. They actually look at the occupation column. It's actually an occupation column. By setting, I didn't show here, but by goes to setting, you can select which one you want. By setting, there's a called X row, the key. So you can select this column called occupation column. Then they're going to distribute the data by this occupation. So you have a different pie, like how you will see how many people, in this case, how many people, how many customers are in different profession, like a worker or farmer, a technician. So this is the one way to look at data distribution. It is important that in the Oracle machine learning, especially in the data preparation phase, you have to look at the data different way. This is actually very commonly used by data scientists to understand the data. This is another way. If you want to look at a different way, I can select it. In this case, key. So I can select it by selecting this called a bar. This histogram. So if I want to show histogram by the job, different job content, different job type, then this show like how many people, like 183 people are in health, and this like 90 people in design category. So this is actually show the how many customer count by each job category. So this is another way to look at the data distribution. So this is actually quite important to show that how important this job, the job category is. We specifically look at the data distribution for this attribute. This is one way to look at attribute, one way to look at a distribution. This is another way to look at a distribution. So, okay. So those are some of the tool. Now I will spend the next probably 10 minutes to show how we actually do this. So this is a actually example that you actually can do. I will show you. This this example is in GitHub. So I have the link to show this is called one of the lab to use to show machine learning. So this example is to show to predict the customer credit score. So they also actually do two models: customer credit score, also customer spending. So they were going to predict for a particular customer what's the credit score, or for particular customer how much buying power they can have. So this based on this query, based on this table. This is a table. This table 100,000 row. This table has the data we're going to use to build a model has all the data, including the credit score. So we know each customer what is credit score. But we're going to use that data to train model so that when we have new customer in, we can base on some of the data here to predict their credit. So that is this example. And yeah, this example is in this GitHub. So in order to run a machine learning, there are two major phases. One is to prepare your data, understanding your data distribution, prepare your data for machine learning. After you finish that, you can build the data model. Here's some of the major step of each phase. First, you prepare your data and understand the data. So, for example, we just showed we want to understand the data distribution, how important, for example, how many people are in good credit, how many people are in bad credit. Then we're also going to find out those attributes, most top end attribute that could relate to good credit. So, for example, the income, profession, wealth, family. Then after that, we're going to split this data into two parts. One is called training data, one is called test data. Training data help us to build a model. Test data help us to invalidate to the accuracy of the model. So once we have this one, the second phase is we take the training data, we do some setting to tell the procedure that which model, which algorithm you're going to use, and also relate to the parameter for this algorithm. Then the DBMS, the data mining create model procedure will create a model and save the model in the table. Then after we create model, we're going to evaluate how good this model is. We take the model, we take the test data to show. Importance in this test data, we use this model on the test data to calculate the predicted credit. Then we use the predicted credit to compare with the real credit to show the difference. The difference is stored in this called lift result. And this lift result is a single indicator to show how good this model is. If this showed the model is good, then we are ready to use this model to do for prediction for new data. So that is the process. So let's spend a few minutes, finish the process. First, we just discussed, we want to use prepare the data. So understand the data, we use this pi to do it. Yeah, so this also shows how many people are good credit and bad credit. So we want to understand the distribution. You will see not only the query is important, all the graphical interface is so critical for this model understanding. Excuse me. Then some of the data column, some of the columns actually the continuous data like a credit, like for example, someone has credit like a 700, someone credit 699, and in order for machine learning to process, we have to put all those in a different bin. So for example, we treat credit from 600 to 699 as the same, one bin. So we pretty much like in this case, we put 10 bins. So each has a range. That's how it's important that for machine learning to understand, because the machine learning right now is built to process this bin, not by continuous number. So then after that, we can show the data by bin. So in this case, each bin, by each range, how many people are in each range. instead of showing each particular numbers. Then next thing is we actually split, or we also want to, next step is understand what are top attribute. And this could be very difficult for manually look at it, but nice thing about this, Oracle already have this pre-built procedure called DBMS predictive analysis procedure. The package inside the package is called explain package. The procedure, that procedure will help us to find the top attributes and rank them. So this is actually, you just call this procedure, they will do it, and they put this rank into this bin table, into this this table. Then once you finish that, you just need to run SQL query on this table. They're going to show this is actually the rank importance. The importance they show from top to small. So top for credit history, top one is wealth. How many people you have, how many money you have bank. That's the most critical one, and profession and the income, and yeah. So those are the top attribute, and we're going to use those top attribute to do the model building. Like for example, if your customer have attribute like address, those probably will not be selected for machine learning model building. Yeah, so you can just select this table. This is one way to show. This is another way to show that. So by this table, so you can by the importance rank, also by the rank. By rank also the correlation, like how important this attribute is. Now then, after you select the attribute, we split this table into two. 60% in the training data and the rest of 40% in another test data. It is important that this data selection is random. You don't want to select all the people from one professional or one income bucket, like for example, 100,000. You don't want to do that, because if you just select those unrepresented data, your model will not be accurate. So it's important to use the random. So this is why it's random. Then after you select data, you can you do all the setting, including select which model and all the parameter, and which algorithm you use, called the decision tree. That's something we're going to use, and all the other. If we want to set this algorithm, you have several parameters you have to set it. So you can see that all this is done by this inserted by table. So the single data structure for machine learning in the OML is table. Then this is actually procedure to build data model, create model. So we take the model, we take the data is here, and I also have bin a setting. And once the model is built, the model is stored in the N1 class 1 table. This actually is a table. And the nice thing about it, if you have a table, which means as a database professional, we know we can export and import, we can move around, and that's quite simple. Then, okay, so then after we build it, we're going to show how good this table is, the model is. We call this called applied model. So basically, we take the test data, and we run this model against the test data. Then we can calculate the particular result. So then we use the particular result to compare with the real result. So we calculate this is called computer lift. So lift basically calculate the difference between your real result and your predicted result. Predicted result is from model. So in this case, by see the difference, we can see how good your model is. So how to evaluate the model? We use this called gain and lift chart. So here is the gain lift chart explanation. So if you don't do machine learning, you just randomly, this will be like a straight line, and the real case is this blue line, a green line, and the blue line is actually your model come up. So you want to see that this model is more close to the real. More curve you have is better. If you have less curve, that means your model simply does not do anything. It's random. So here in this example, we show this little bit, it's actually pretty good curve. It's very difficult to get 100%, but it's actually good result. So in this case, we know this, if this data was like a flat line, that would be not good. So, okay, so once you have model, then we can basically to show, to apply this model. So in this case, single query to apply model. So we have new data. We can use this model to predict it. So let's say if we have a 500 new customer, then I can use this model to calculate the credit for each of this customer by using this query. This is a single query, but if you want to store that prediction in the table, you actually can create this table, create table as selected. So this is actually this query is a fixed, so it's a part of a data mining procedure, and you can run this query in DW or in your regular Oracle database. So yeah. Then yeah, so this basically show you, this is the result show you for this particular customer, what is the probability of for this customer to have good credit. So this is 100%. This is actually quite important that if you have a credit card application, if customer apply the credit card, you want to know if what's the probability for this new customer have good credit. So if you have 100%, then you have high confidence that you can give them the credit card. If other customer, I didn't score the whole data, but some of bottom one, you have a 20 or 30 or even 40% to be good credit, then you probably don't want it. So in your business, you probably will establish the threshold. Let's say, anyone that has 70% probability, I'll give them credit card. Anything below 70, I'm not going to give them credit card. So this is actually help your business, and also this also can this query actually can. Important thing is we want to embed this query in the part of your application. So we don't just calculate this for fun. We want to have this query built inside database, inside your application. Let's say if you have credit approval application. So your credit approval application can actually embed this query into your application to calculate the probability. Then you have a business logic to see if this number is up to is above 70%, then you give them you have a business logic to approve the credit card. If number is below to 70%, you reject the credit card. So in this case, this one, but this particular customer only 51%. So up to you whether or not you want to give them credit card or not. But at least I have this capability to calculate the probability. For this customer has have good credit. So that is the whole process we use this example to show how we build a machine learning inside autonomous database. So all this example, as we discussed, this example is actually you actually can try this example. Our thing first, you come here. Try some more example. These are a little bit more simple. Then once you have enough information, then you can just come to this GitHub, download this. This actually has 3 labs. From beginning, you actually have the low data, and low data because this 100,000 data raw data is not in the AW. You have the low data to the AW autonomous data warehouse. But all the code is actually here. So you have 3 level 100, level 200. Those are like how you build a database, autonomous database, how you load data. 300, start with 300. You actually run in you go through this example. So let's give you at least for learning curve. Well, obviously once you learn that, you actually can, if you have your own business, you actually can start developing the machine learning applications. So that is the one. That's as much as I want to cover that. There's actually quite a few reference because this presentation actually cover several areas. So I just want to highlight One is the Oracle Machine Learning Insight Database. So you have all the algorithms inside database. And that part, you actually, if you want to try that part, actually, you don't have to come to Autonomous Database. You actually can try in your regular Oracle database. All the algorithm is inside Oracle database. The algorithm we just show, even in the example, all the algorithm is inside database. Only thing you don't have is actually the machine learning notebook. So if you want, you actually can get your own notebook, you connect to a database. That takes some work, but it's possible. But the nice thing about the autonomous database is you don't have to build your own database. For learning purposes, quickly, maybe take you a few hours, maybe take a autonomous database house is like only building one database instance is like only 10 minutes. Then after you know that, you can start log into a machine learning and run all the examples. So, so rest of this is depend on machine autonomous database. But the top one you really is part of Oracle RDBMS 12c feature called Advanced Analytical Option Features, which is part of already part of Oracle database. So yeah, so this is if you want to know more, definitely there are excuse me, a lot of reference. I want to mention the Charlie Berger is actually the senior director for this product. He has a lot of blogs, you can read it, and the moving data, not moving algorithm, not data. That is pretty much the logo, that this whole Oracle machine learning feature is about. So yeah, so that's all I want to cover, and hopefully this give you the introduction about this new area. I know not many people actually, because we all work on database, the machine learning is kind of relatively new areas, but this gave us some introduction for us to further explore. Myself is also on the path to further learning this piece. Okay, that's all I want to cover, and thank you. And question QA, yeah, any questions? I will be very happy to answer.
Thank you, Kai. Yes, we have 3 questions in the Q&A section. Please, could you check them?
Okay, let's see how to do the Q&A section. Oh, yeah. Okay. Yes, the first question is machine learning is included in ATP. Yes, it is a part of ATP, but I have not covered that. It could be a little bit different. Myself, I actually have not explored that, but it is a part of ATP. Another machine algorithm in all, yeah. So I think starting also Oracle 12c, the 12c has all the machine learning algorithm inside database. Oh, certification on autonomous database. I think they have some, yeah, they do have some certification called an OCI. I know they have a cloud certification, but I'm not quite sure. Autonomous database, definitely autonomous database is a part of a cloud certification, but I don't know if they actually have a specific certification for autonomous database. That's something I have to explore that. I don't have any definite answer for that. Yeah, but I know have OCI certifications. Yeah.
Thank you, Kai. I think that's all the questions. Well, thank you, Kai, for your excellent presentation. I'm sure it has served us a lot. Gracias, Kai, por tu excelente presentación. Estoy seguro que nos ha servido y ayudado muchísimo lo expuesto. Once again, thank you all for joining us, and we will finish the session. Thank you, Kai.
Thank
And
you. Thank you.
see you soon.
Yeah, see you soon. That's something I really hope for. And see you soon. Yeah. And once again, thank you for attending the session. Thank you. See you next
Thank you.
time.
Bye.
Bye.